transmission line characteristic impedance. Everybody knows what transmission line characteristic impedance is, right? Because this is important for the formulas we're going to use. A transmission line has a characteristic impedance. We're all familiar with 50 ohms and 450 ohm ladder line. Characteristic impedance of the feed line is defined as the line's input resistance when the line is infinitely long. Specifically, it's the ratio of the amplitudes of the voltage and the current along the length of the line. And recall that the amplitude of the voltage and the current waves along the transmission line will remain the same unless acted upon by a reflection coming from the far end. So that's the whole point about the infinite line, right? If you measure an infinite line, it's going to measure whatever the characteristic impedance is, because with an infinite line, you have nothing at the end. So you have no reflections coming back. Maximum power transfer, no reflections, happens when a feed line is terminated in its characteristic impedance. This means that power applied to the line is completely absorbed by the load attached to the far end of the line if the load is the exact same impedance of the line itself. So basically, this is how you can tell what the characteristic impedance of a feed line is. You got a big roll of coax, all the lettering is gone. What's the characteristic impedance? Put a variable resistor on the far end and an antenna analyzer on the other end and tune the variable resistance until the SWR drops to 0. And whatever that reads, that's the characteristic impedance of the feed line. Question?